Okay, here we go with defining what a logarithm is. Okay, please be patient. It'll take me about a minute or two to get there. Let's say that you are asked to find f inverse of x if f of x equals 2 to the x power. Now you should know that this is an exponential function. If you take 2 to the 0, you get 1. 2 to the 1, you get 2. 2 to the 2, you get 4. 2 to the minus 1 is 1/2. 2 to the minus 2 is 1/4. You get these growth or decay functions that we've been working with. Okay, let's do the procedure you learned in the last video. F of x is equal to 2 to the x power. So we write y equals 2 to the x power. That's our function. Now we want to write the equation for f inverse. So we change y to x and x to y. And now that we've done that, we need to try to change this so that we get y equals something, so that we can say f inverse of x is equal to whatever it is we get. The problem is there is no way, to take away all the fun of trying to do it, there is no way to talk about there's no way to get that y out of there. There's no way to change this equation so that it says y equals with anything that you've learned before. Now basically it requires making up a new notation. We have to understand that y is equal to the exponent of 2 that gives x as a value. Okay? So like if x is, let's do this, if x is 8, 8 is 2 to the third, so we're saying y is 3. It's the third power of 2. It's the exponent of 2 that will give an answer of 8. And the way mathematicians came up with this is we say that y is the log of x base 2. And so this is a new notation for writing this concept, and this is what you need to learn. Now you want to focus on bringing this guy down, x equals 2 to the y, and this guy, y equals the log of x base 2. Okay, this is what we need to focus on, these two things. Now let me slide the page up here a little bit. Oh, that defining a logarithm doesn't seem to want to slide up. That's interesting. I learned something new just now. Okay, you need to learn to convert from log notation to exponential. This is exponential. I hate these little styluses. That's exponential, and this is logarithmic notation. So when we write 5 squared equals 25, you need to get good at saying, oh, that's the same thing as saying the log of 25 base 5 is equal to 2. My suggestion is you take a very simple example like this, memorize it, don't forget it, and whenever you get confused on other problems, you go back and you look at this and say, this is the way to do it. So apply the same change, the same principle to the problem, and you've got to have it right. Now, the kind of problems I'm going to pause here for a second. Okay, I'm back. I just realized, just for your experience, you don't feel like I ever left, but it's been about 5-6 minutes since I paused making this video. Anyway, I'm going to ask you to do some problems from page 253. Now, we have moved into section 4.3. Chapter 4, section 3 is logarithms. Well, it's entitled logarithmic functions. We'll just put logarithms. Okay, so we're just starting section 3. This is the first thing we've done in section 3. Now, some of the things we're going to do is ask you to write things that are written exponentially. Like they'll have things like 10 to the minus 2 equals 1 over 100. This is exponential form. They want you to put it in log form. And you would say, well, the log of 1/100th. And it's good to put it in parentheses if you have more than just a single number that you're doing the log of. The log of 1/100th in base 10 is a negative 2. Now, some other problems are going to be like, what is the log of 1/9 base 3? And that's it. That's the problem. My suggestion, there's no equation. They just give you this number or this expression. And you're asked, what's this equal to? Well, my suggestion is make it equal to a variable and then rewrite it exponentially. Practice rewriting it exponentially. Now, I think some of you'd be able to look at this expression and figure it out. But if I make it equal to x, then I can convert it to saying, okay, this says that I'm going to take the number 3, I'm going to raise it to the x power and get 1/9. And then all I have to do is realize, well, 1/9 is 1 over 3 squared. And 1 over 3 squared is 3 to the negative 2. So 3 to the x equals 3 to the negative 2. X equals negative 2. Okay, I would suggest that you show some work like this when you're given a problem like find the log of something. Make it equal to x and rewrite it as an exponential equation. Now, I kind of went over this stuff here, this work. We're going to talk about that some more at a later date, but for right now, this video is over. Go do the problems from page 253 that you find on the homework page. Thank you very much. Toodaloo.